Welcome back, everybody. Today we're going to talk yet again about confidence intervals, but this time how to find a confidence interval for a population proportion. All right, so I went through the motivation for confidence intervals in a prior video, so go back and take a look at that if you need to. I'm just going to jump right in and talk about some of the notation and some of the things that we're looking for. All right, so some of the notation that we haven't seen for a while. The first is p, lowercase p. All right, and you might remember that is the proportion of success. So whatever success means, it is the proportion of success, and note that this is for the population. So if success is rolling a 6, success is having blue eyes, success is having blonde hair, whatever success is, P would be the proportion of the population that has that characteristic or had that success. P hat is the sample proportion of success. All right, and the last one we need, I'll make it better, is Q hat. And Q hat was the sample proportion of failure. All right, so let's start with a little bit of review and talk about how to calculate a proportion. All right, so let's say we were doing a survey of our class and we wanted to know the proportion of people with blue eyes. I'm picking that because I have blue eyes. I would be considered success. So let's say out of 35 students, all right, in our class, that would be the population. Let's say, I don't know, 10 had blue eyes. All right, in order to make a proportion out of this, right, we would do the number of successes over the total number. So that would be, in this case, 10 out of 35. And we can simplify that to 2/7. And that would be our proportion of success. If 35 was our population, it would be P. If it was our sample, because our population was, let's say, the entire university, it would be P hat. All right, so, and how do we calculate Q hat? That would be 1 minus P hat, because P hat plus Q hat, that should have been a Q, has to equal 1, right? If it's success or not. So for our point estimate, right, our initial estimate, of our population proportion, let's use, I could have used that, sample proportion, or P hat. All right, now remember, we don't know what P is. We're going to use P hat as a starting point. All right, so let's say we had some experiment and there were 280 trials, and we had 120 successes. All right, to get our, 280 is our sample because there's more people in the world. So our p hat is going to equal 120 divided by 280. Why don't you guys pause the video and let's see what that is. And that should equal 0.43. Sounds about right. Okay, so we're comfortable with how to calculate a proportion. All right, so our typical confidence intervals we're going to work with are, once again, 90%, 95%, and 99%. All right, and we're going to go back because we're using larger numbers, right? Our sample was 280, that kind of a thing. We're going to go back to z-score. So our z-score, I'm just going to put alpha divided by 2, right? Alpha divided by 2 is going to be 1.65 for 95%. Is going to be it's not a 1 at all. 1.96, and z alpha divided by 2 going to be 2.58, just like they were before. All right, and once again, alpha is the unused area. So alpha at 90% would be 0.1. Alpha would be 0.05. Alpha would be 0.01. So that is that. For our error estimate, margin of error. We're going to denote that with an E. We start with Z alpha divided by 2 times the square root of P hat, Q hat, divided by N, all under the square root. All right, and like I said, I typically like to find out E rather than put it in a very large equation. All right, so our confidence interval, right? Putting it all together, we're going to have P hat minus E is less than P, which is less than P hat plus E. Okay. All right, so let's jump right in. A survey of 1,721 people found that 15.9% of individuals purchase religious books at a Christian bookstore. Find the 95% confidence interval of the true proportion of people who purchase their religious books at a Christian bookstore. All right, so I always like to state the things that I know first. All right, so things that I know. I know what P hat is, because P hat's right here. So my P hat equals 0.159. And if I know my P hat, I know my Q hat as well, because it's 1 minus 0.159, which should equal 0.841. All right, I know that I have a 95% confidence interval. So my Z alpha divided by 2 is going to be 1.96. All right, so those are things I know. Okay, so now I'm going to scroll up a little bit. I'm going to keep those things I know on the screen as long as I can. But I want to calculate my error. So my error is going to be 1.96 times the square root of 0.159 times 0.841 over 1721. So why don't you pause the video now, do the calculation, and we'll talk more on the back end. All right, so hopefully you paused the video and did the calculation. I got 0.17 as my error. So now I'm going to take that error and I'm going to plug it into my confidence interval. So I got 159 plus 0, not plus, just kidding about that, minus 0.17 plus 0.17 right here. So when I add and subtract, I get 0.4142 less than P, which is less than 0.176. All right, and again, you should always end with a sentence, writing something like, one can say with 95% confidence that the true percentage of people who buy their religious books at a Christian bookstore is between 14.2% and 17.6%. Okay, so for my second example, I want to do something slightly different. All right. So let's just jump right into that. Okay, so example, a researcher wants to estimate the proportion of executives who own a car phone. She wants to be 90% confident and accurate to within 5% of the true proportion. All right, and the question is, find the minimum sample size. All right, so we're going to attack this a little bit differently. All right, and the first thing we notice is that we have no p hat or q hat. All right, so if we have no p hat or q hat, researchers assume that it's 0.5. So those are acceptable numbers to use. And if we scroll up, we notice that our margin of error, if I took that and I solved for n, I could get my sample size. All right, so we are going to do that. So why don't you pause the video, do that, and we'll talk more on the back end. Okay, so hopefully you did some algebra on that formula. I wound up with, not m, just kidding about that, n equals p hat, q hat, z alpha divided by 2 over E, the whole thing squared. And you can use this. I mean, you don't have to redo the formula every time. All right, so in this case, we're using 0.5 for P hat and Q hat. And our Z is 1.65. And our error, we want to be within 5%. So there's our error squared. So why don't you pause the video now, do the calculation, and we'll see where it takes us. All right, hopefully you paused that video, did the calculation. I wound up with 272.25. Now, my final answer, unless otherwise told, I have to move it to 273 because I want to be within 5% error. 273 will get me inside 5%. If I did 272, I would be outside that 5% error. So 273 is the sample size. All right, so it's not about mathematical rounding, it's more about being within the 5% error. All right, there's plenty more practice to do, but hopefully I gave you a good start. Thanks for listening, and I'll see you next time.